All right, we can now move on to my favorite part of this whole class, and that is Chapter 3, where we talk about derivatives. We're starting, of course, with section 3.1, which is defining the derivative. We have a few terms we need to talk about first. So first off, definition. A secant line is a line that intersects a curve at a minimum of two distinct points. At least 2 points. So what I mean by that, let's say I have a graph. This is my basic go-to graph whenever I need one. Don't really know why, but there we go. And let's say a secant line could be like this. I'm passing through at least 2 points. In this case, I'm passing through 3 points. But it has to be at least 2 points. So let's look at these 2 points right here. This point and this point. Okay. Let's say I knew the value of this point was an x, and I knew that to get from this point to the next point, I have to go over by h. That would mean this point is going to be x plus whatever that h is. Okay, so this value is the x, so then this point is x plus h. So if I wanted to know the slope of the line, okay, I only need those 2 points. So remember, our formula for slope is my change in y minus the change in the x. Okay? So the y of point number 2 is f of whatever x plus h is. Okay? Minus the y of my first point, f of x. Over x2 was the x plus h part, minus the first x, which was an x. So if I reduce this as much as I can, I see the slope of a secant line is found by doing f of x plus h minus f of x over h. Okay. Now, the term that I really need for this class is a tangent line. Okay, a tangent line. Definition, let's define what that is. A tangent line is a line that just touches, put that in quotes, a curve at one point locally. So now I just want to look at 1 point, whereas these lines I talked about over here pass through at least 2 points. I'm looking at just 1 point that says locally. That looked like a B. I just want to make sure. Locally. So what I mean by that is that if I just look at 1 point, I'm just barely touching it at this 1 point. Now, it might pass through more points as I go, right? Because like here, this would keep going up. So I would pass it at like more points, right? But I mean, around here, just touching 1 point. That is a tangent line, okay? So what I want to do is I want to actually use the slope of a secant line to figure out what the slope of a tangent line is. So remember, we just said the slope of a secant line is f of x plus h minus f of x over the h, right? Now, if I'm only passing through 1 point, h would be equal to 0, right? But we can't divide by that, so it doesn't make sense to plug that in. But as we learned in chapter 2, I can see what happens as h gets close to 0. So the slope of a tangent line is the limit as h approaches 0 of f of x plus h minus f of x over h. That's how I find the slope of a tangent line. This is a big deal. You need to remember this because we're going to use this a lot throughout this class. So that's how I find the slope of a tangent line. Let's do some examples of finding it. Example. Find the equation of the line tangent to the graph of f of x equals x squared at x is equal to 3. So I'm looking for the equation of a line. Remember, the best way I can do that is to use point slope form, which we said was y minus y1 equals m times x minus x1. So I need a point and I need my slope. Well, I can find a point because I want it at x is equal to 3. So I can plug 3 into the equation and it will give me my first point. So f of 3 is going to give me a point. So that's 3 squared. 3 squared is equal to 9. So I know I have the point 3, 9. So I can start there. Y minus the y I know is 9 minus my is equal to my slope, which I don't have yet. X minus the x I know is 3. So now I need to find my slope. Okay. Well, as we have said, to find the slope of a tangent line, we do f of x minus or x plus h. Well, for this case, my x is equal to 3. So 3 plus h minus f of the x, which we said x is 3, all over h. And so I just have to work this out, and that's going, the limit, I forgot to write the limit, as it goes to 0 of all of that stuff. So f of 3 plus h. So that's going to be 3 plus h squared minus f of 3, which we already said was equal to 9, all over h. That's going to give us the limit as h goes to 0 of 3 plus h squared. I would write 3 plus h twice and multiply that out. 3 times 3 is 9. 3 times h is 3h. H times 3 is 3h. H times h is h squared. So you get 9 plus 6h plus h squared. So now I have 9 plus 6h minus h squared. But then I still have minus 9 all over h. On top right here I see 9 minus the 9. So those cancel out. So we just have 6h minus h squared over h. Notice here, every single term has an h, so cancel all of those out. So if I cancel an h from every term, I would just get 6 minus 1h. So now that I have it like that, I can plug 0 in for the h, plug 0 in for h, and you see the answer is 6. So the slope of this line is equal to 6. So now I can plug that in for the m. Y minus 9 equals 6 times x minus 3. And then I can solve that for the y. So distribute our 6. Y minus 9 equals 6x minus 18. Add 9, and you see y equals 6x. Negative 18 plus 9 is negative 9. So that is the equation of the tangent line of x squared at x equals to 3. The big thing there is to remember point slope form, which is this right here. This is point slope form. Remember that. And then remember how I get the slope is the limit as h goes to 0 of f of x plus h minus f of x all over h. Let's do another example. Find the equation of the line tangent to the function f of x equals 1 over x at x equals 2. So again, here we're going to do the same thing. I want to put it into point slope form. Point slope form is y minus y1 equals m times x minus x1. Sorry, trying to talk too fast here. So first thing I need is a point. I can get a point by plugging in 2. F of 2 is equal to 1 over 2. So that gives me the point 2, 1 over 2. So again, that y minus the y that I know, which is 1/2, is equal to m, which I don't have yet, times x minus the x I know, which is 2. To find our slope, remember to find the slope of the tangent line, that's the limit as h approaches 0. F of x plus h, so for this one that's f of 2 plus h, minus f of x, which would be f of 2, all over h. So that's going to be the limit as h goes to 0. F of 2 plus h, if I were to plug that in here, that'd be 1 over 2 plus h, minus f of 2, we already said was 1/2, all over h. We can use our skills from chapter 2, and we know we can multiply this by the least common denominator. So 2 times 2 plus h, top and the bottom. So how that's going to help us out, whenever I do 1 over 2 plus h times that stuff, the 2 plus h is going to cancel out. So I'm left with just 2 minus. When I do 1/2 times that, the 2's are going to cancel out. So I'm left with minus 2 minus h all over 2 times 2 plus h. Or h. Let me rewrite that. H times 2 times 2 plus h. On top right there, I have 2 minus 2, so those are going to cancel out. Limit as h goes to 0 of negative h over h times 2 plus h, and then cancel out the h's. So that's going to be the limit as h goes to 0 of 1 over 2 times 2 plus h. Plugging in 0 for the h gives us 1 over 2 times 2, and 2 times 2 is 4. So we get 1/4 for the slope. So now I can rewrite this as 1 minus 1/2 equals 1/4 times x minus 2. So now I have everything I need, so I just need to solve that for the y. So distribute our 1/4. Y minus 1/2 equals 1/4 x minus 2 over 4 is 1/2, so 1/2. Then to solve that for y, just add 1/2, but the good thing there, they cancel out. So it's just y equals 1/4 x. And I am realizing now that I'm completely done with the problem, this should have been negative. So negative 1/4. So that should have been negative 1/4, which I made it negative 1/4 plus 1/2. So negative 1/4, then when I do 1/2 plus 1/2, that's 1. Sorry about that. Should have been negative 1/4, not positive. But that was just a small change. It didn't really change a whole lot. All right, let's do another example. This one just says find the slope, so then we only need the slope. Find the slope of the line that is tangent to the graph of f of x equals the square root of x, and I want it at x is equal to 4. So for this one, they only need the slope. They don't want the whole thing. All right, so remember to find the slope of a tangent line. That's going to be the limit as h goes to 0 of f of x plus h, so that's going to be 4 plus h for this one, minus f of the x, so f of 4, all over h. Let's figure this out. That's the limit as h goes to 0. F of 4 plus h would be the square root of 4 plus h, minus f of 4. F of 4 is the square root of 4, which is 2. So minus 2 all over h. Again, if we use our skills, we know to multiply this by the conjugate. So multiply by the square root of 4 plus h plus 2 over the square root of 4 plus h plus 2. That's going to give us, remember we did this in section 2.3, so if you need any help with that, you can either go back there or let me know and I'll help you out. But the good thing about this is I just square my first term. The square root of 4 plus h squared is 4 plus h minus, and then square this term, 2 squared is equal to 4. All over h times the square root of 4 plus h plus 2. On top right here, I have 4 minus 4, so that's the limit as h goes to 0. 4 minus 4, those are out of there, so it's just h over h times the square root of 4 plus h plus 2. And then I can cancel out the h's, so that's the limit as h goes to 0 of 1 over the square root of 4 plus h plus 2. And that's good because now I can just plug in 0 for the h. So 4 plus 0 is equal to 4. The square root of 4 is 2, and 2 plus 2 is 4. So that's 1 over 2. So our slope, 1 over 4. I'm going way too fast. Right, because I put 4 plus 0, which is 4. Square root of 4 is 2. 2 plus 2 is 4. So 1 over 4. For this one, they just said slope, and so I can just stop there because they only wanted the slope. So, this slope has a name. There is a name to represent the slope of a tangent line. Definition. Let f of x be a function defined on an open interval containing the number a. Containing a. The derivative of the function f of x at that number a, which is denoted as f with a apostrophe, so f with an apostrophe a, that's like saying f prime a. F prime a is the slope of the tangent line at x equals a. So this slope we have done is called the derivative. The derivative is the slope of the tangent line. So let's do some examples. Let's let f of x be equal to x squared plus 3x plus 2. And I'm going to say find f prime of 1. So what this means is I want the slope of the tangent line at the 1. That's what this means. So f prime of 1 is equal to the limit as h goes to 0. Remember, it's f of x plus h, so for this one it's f of 1 plus h, minus f of the x, so f of 1, all over h. Let's figure that out. Limit as h goes to 0 of, plug in a 1 plus h, so 1 plus h squared plus 3 times 1 plus h plus 2. Then if I plug in a 1, I get 1 squared, which is 1, plus 3 times 1, which is 3, plus 2. 1 plus 3 plus 2 is 6. So it's 6 minus 6. All over h. Let's keep working this out. 1 plus h squared. If I were to square that, we would get 1 plus 2h plus h squared. Distribute 3 over here, so plus 3h, and then plus 2 minus 6 all over h. Let's see what happens there. 1 plus 3 is equal to 4, plus 2 is equal to 6, minus 6 is equal to 0. So I can actually cancel all of those out. So I'm just left with 2h plus 3h, which is 5h, plus h squared over h. And what's good about that is all of those have an h, so cancel out the h, which is leaving with 5 plus h. So now I can plug in a 0 for h, and I get 5. So f prime of 1 is equal to 5. Again, it's the same thing as just finding the slope like we have done. Let's do another example. Oh, actually, that's it. That is the last example I have. So that is what a derivative is. It is the slope of the tangent line at a certain point.